In this video, we're going to look at the min-max delta function of the Sylvac high cap. The min-max button can be located on the left-hand side of the keypad, labeled with min, max, and delta. The first time you hit that button, we enter minimum mode. The second time we enter maximum mode. The third time we enter delta mode, delta being a TIR, the difference between the min and the max. What we're doing in these functions is we're going to tram our probe across a surface, and we are going to locate the lowest point of the surface in minimum, the highest point of a surface in maximum, or the difference between the lowest and the highest point in delta being a TIR. If we were to use a feature such as this wavy slot, where we can tram our probe across a surface and locate the distance for the lowest point or the highest point, we can engage our probe, tram it across those surfaces, and locate those distances if my 0 is coming off of the plate, effectively calculating the wall thickness of the part. I'll go ahead and I'll tram this surface in our minimum mode, and I'll locate the lowest point in that valley. So if I come into this surface using the same principle in diameter mode, setting myself slightly off-center from that low point, engaging my probe, now as I tram through this surface, my display is going to count and get lower and lower and lower and lower. Eventually, it will freeze, and now I'm starting to work my way back up the other side of the slope, so it is locked in on my minimum function. So at 344 thousandths, we have calculated the lowest point in that valley. If I release the contact, the gauge will work just the same. In maximum, if I engage the probe again, and now I work the probe up and over that peak, it will get higher and higher until it locates the reversal point, capture it, and at 372 thousandths, the gauge is locked on the maximum or the peak of that point. If I release the probe again, I also have a delta function. The delta function can be used many different ways. If I drive up to the top of the surface and I engage delta mode, if I engage my probe onto a surface, it will zero out the display, and now I can tram on that surface. If I were to tram the perimeter of this part, I'm given a value of 1 thou 8/10. Effectively, that value is the parallelism of this surface. Parallelism based because we are sitting on the bottom of the part in my surface plate, so all of my measurements are relative to the surface that my part is sitting on. Therefore, we have a parallelism value. I could take my part and I can put it on 3 levels, jack it onto 3 levels, and I could tram underneath the surface to calculate a flatness value. And I can also take a turned part and I can put it on the V-block to measure runout. To give you an idea how a runout measurement will be captured, I have a V-block with a precision pin here. If I engage my probe in my delta function, if I engage my probe on my turned part, so as you rotate the part 360 degrees, we're given a value of 2/10 of an inch, giving me the value of my runout for my turned parts.
Pretty